Hello everyone, in this video I want to using the notebook regression core VIF notebook demonstrating how you can calculating correlation metrics and the VIF measurement to measure the multicollinearity, and also how to get a regression output. So for the regression output I will have the separate videos, and so as you're learning this Python coding, so make sure you have all the software you need to download it, and also upload the notebook and the dataset to your Jupyter Studio. Okay, so the dataset we're using called the Tractor 7. So I will walk through the code, help you understand what we are doing here. Okay, and so for the notebook, as you are seeing here, I list out the purpose of this notebook, and after that we have one section called import OS, import panda as PD. So those are the packages we need to use in this analysis. So make sure you are importing them by since you are using this notebook, please do not change any code in this part. Okay, so once you move your mouse inside this cell, and we're gonna run this cell. Okay, so there's two ways to run it. So the first way is going on to the top, called the run selected cell, right? So you can choose this one, but also on the right hand here they told you a shortcut on your keyboard. That means you do not need to always come here collecting run selected cell. If you're using the Windows computer, as I'm using here, and I can just use Shift and Enter. I will push both of them together. It will also run the cell. So if you're using Mac, I believe there is a different command here. Make sure you follow the instruction on your own computer to find the shortcut. So from the rest of the video, I will use Shift Enter to run my cells. Okay, so again, let's put my mouse inside this first cell, and I will go to run this cell, and I will do is push Shift and Enter together. Push Shift first, and then push and hold it and push Enter. Okay. So now as you notice that it was a star and then changing to 3. So because the star means the computer is running and trying to importing those packages to your computer. Okay, so those are the packages we needed for getting the regression output, getting visualization, and also calculating the VIF. So after that, you will be able to see the second cell here. So for this second cell, I create this formula for you so you can directly run the linear regression models. And then, so of course, if you are trying to learn Python itself, and you actually need to code in this part by yourself, but for our class, you don't need to actually learn how to what this function means. You just need to know, okay, great, Dr. J creating this function, and I can use this function to run the linear regression model. Okay, so now we move to the second cell here. We're gonna run this so that the computer will remember this function Dr. J created, and push Shift, hold it, and then push Enter again. So as you see, it's become 5 now. So now we move on. Now we start to importing our data. And so df equal to pd read Excel. So this is a reading Excel file. As I said, for this exercise, we're using an Excel file called a Tractor 7. Okay, so if this file is not uploaded in your environment yet, make sure you watch the other video in terms of how to upload in your Excel file to Jupyter Lab. Okay, so this is the file we will use, and as you see, I'm not only just including the name, but also the file types, right? So the file type has to match. Since here is reading CS, the Excel file, so here has to be XLSX. So in some situation, your data set might save in the CSV file, okay, instead of Excel spreadsheet notebook. So you need to change in here corresponding to CVS and CVS, okay. So make sure you match. Like I said, for this class, I was gonna give you the Excel spreadsheet book, and then so therefore you just use whatever I have here. The only thing you need to modify if you want to use this code for your data set is to changing the file name here to your file name. Again, make sure you're gonna upload your Excel file to this environment first. Okay, so then after that I had the df again because I creating this Excel sheet instead of Tractor 7 in my notebook. I call it the df, which is data frame. And then I type the df here again. It's allowed me to preview the data set I have in this Excel sheet. So I will run this file, push Shift and hold it and Enter. Okay. this is my data set. So if you are curious if this match, feel free to open this Excel file on your own computer, download it, open this file, okay? And so you will see it's exactly the same. So this just allow you to see the Excel, the data set a little bit without actually opening Excel file. So as you notice, we have sale price, horsepower, age, engine horse, diesel, forward, manual, etc. Okay, so only sale price, horse, age, and engine hours. So those are quantitative data, and the rest of them are category data. Therefore, they're all 1 and 0, so they are dummy variables. And then one thing I also want to call out in this data set we have here is actually using the variable we see here, horsepower, age, engine hour, etc., to predict the tractor's sale price. So therefore, the sale price will be my y variable. Okay, so this is my data set. Now we move on to the next cell. So this is the command I want you to remember. Okay, dot CORR. So this allow you to obtain the correlation matrix. And the before that is the DF. Remember, the DF is the data frame or the imported data set to this Jupyter notebook. The DF is the data set. So we use DF dot COOL that allow us to obtain the correlation matrix of all my x variables and y, because we are literally to find the correlation matrix for every variable we have in the Excel spreadsheet. So you will be able to see the correlation matrix among all of them. Okay, and then again, so if you name your DF differently here, and you have to make sure you're correspondingly changing here. Again, we are learning to use this class. I try to make it as versatile as possible. So therefore, when using this file on your own project, please do not change DF name, because you don't need to change the rest of the code. So the only thing you need to make sure you port it right in the right data Excel spreadsheet, right? The right data set Excel spreadsheet. So the other thing I want to call out is when you have your data set, make sure you only have your first tab exist, and your data only put on your first tab. Okay, otherwise you need to define which sheet it is, so it may be a little bit complicated. So therefore, for your own convenience, please, for your own Excel spreadsheet, make sure you only have one, the data set only hosted in the first tab of your spreadsheet. Okay, now we move on. We're going to calculating this correlation matrix, and we're going to push shift and hold it and push enter. Okay, here they go. This is my correlation matrix. You already read textbook, understand what is correlation matrix. So basically, there are correlation coefficient. Okay, as you notice on the diagonal, it is all ones. So it's called a perfect correlation. Why is that? Because on the diagonal, it's literally just look at the relationship between themselves, right? Sale and sale, horsepower, age. So basically, off diagonal is the one we are looking for. Okay, so for instance here 0.664381, so that is the relationship between horsepower and the sales price. So it is larger than 0.5, so that it means it's a strong positive correlation exists between sale price and the horsepower. Again, it doesn't matter, right? Because we want to see that sale price is our y variable. So we mainly worry about among x variable, there is multicollinearity, right? So therefore, we just ignore my first column and the first row because they are all relative sales price. We're gonna starting from second column and the second row here, okay? If you look at second column here, so this. Oh, here they go. So the cap and the horsepower has a positive strong correlation. It's 0.56, right? So that's the relationship between horsepower and the cap. So we have a positive correlation here. And then we can move on to age. Okay, I'm on age. Seem like on the sale price and age have a little. Oh, so here they go. The age and engine hours. Age and engine hour has a strong positive correlation. And then also, as you see, one thing I want to call out. So there is a symmetric situation. So for the correlation matrix, if you look at, so this value 0.559038 are exactly the same as 0.559038. Why is that? Because they both is look at the correlation between age and engine hour, right? So therefore, that's another thing about correlation matrix is you only need to look at one diagonal, either top right or bottom left. So because they are exactly same. So they are symmetric, and their center is at your diagonal here. Okay, so therefore you can just focusing on the one below your diagonal or the numbers above your diagonals. Okay, so for instance, I move on to the engine hour now. So I only need to look at everything below ones. Okay, everything below ones, because everything above ones will be able to show is related to the one already covered here, right? So therefore only need to focus on one diagonal. So engine hour, if we look at 0.07, negative, negative, positive, positive. So there is no strong correlation between engine hours with my diesel, forward, manual. Okay, so those, and then we can keep moving on. So by using correlation matrix, you are able to identify among all your axes either any strong correlation. If that's the case, we have the multicollinearity problem. Right? So this is one method you can use to identify if your model have multicollinearity among your x variables. Now we use the second measurement called a VIF. So VIF is the metric we can use to measure the multicollinearity. And on your textbooks, so the rule of thumb is if the VIF is larger than 3, so then, larger than 5, we have severe multicollinearity problems. And then again, we are not talking about how you resolve, and what action you need to take. Here we just focus on using VIF. Are we able to identify any severe multicollinearity? Like I said, if it's larger than 5, we have severe multicollinearity problem among your x variables. So when we calculate the VIF, we are looking at within your regression model. So let's say you have 3 x variables. We will look at all 3 together to see if any one of them are highly correlated with the other 2. Okay, so therefore, we need to define our x variable. So we do not want to mingle x with the y variable, because when we calculate VIF, we are not detangling my y variable out. So therefore, as you see the code here, I need to call out the variables that I plan to put in my model. Okay, so I called x. So I need to put all my x variable. I need to call out all my x variables, and then to check on their VIF. So let's see if your idea is to including horse power, age, engine hour, diesel, and forward into your final regression model. And your thought is, you know what? In order to understand the multicollinearity, I need to check if all of the including those variable, I may facing multicollinearity problem. So you type in all the variable name here, and then you don't need to change the rest of them, because it will show you the VIF. Okay, so we're gonna run the model, push shift, hold it, and enter. Okay, now you see that. So among these x variables, we notice that diesel are the one highly correlated with the rest of the x variables. So diesel is the one highly correlated with the rest of the variable, had a very severe multicollinearity problems. And the age has mild because it's very close to 5, right? Close to 5. Okay, so again, I want to do one variation so you know how to leverage in this code. So for instance, you said, you know what, instead of use horse power, age, engine, diesel, forward in my final model, I want to including everything. Okay, I want to including everything. If that's the case, you just need to add in more variables. So make sure every time you call out variable, you need to put a quotation mark. Okay, so this is manual. Okay, so the next variable, I want to including the other one, which is John Deere. And then cap. And then spring. And then summer. Don't forget, put a quotation mark. And then the last one is winter. Perfect. So here is where you can alter in the code. Like I said, if you import in your own Excel spreadsheet, so those variable name will change. So make sure you are changing your variable that you're going to use for your x variables, and then from there, and then calculating the VIF. Okay. So now here they go. This is a VIF for all my x variable I have in this data set. Let me check on the VIF. Okay, look, remember diesel is 61156, so this value will change. Okay. Pay attention on the diesel again. It's a 7.96. It's increased even more severe. So what's going on here? Like I said, when we do VIF, it is very important you identify your x variables if you have 10 x variable, if you only plan to use 3 in your regression model, please only list those 3. Do not include everything you have if you don't plan using all of them for your final regression analysis. The reason is that when we look at the diesel, this one was 6 point something, now becomes 7.9, because when we look at VIF, it's literally to look at the diesel, this variable, how they correlated with the rest of all the x variables. So I do see at the first example, I did not include those variables. So it means diesel has a strong correlation with them, but not as strong as I including all of the x variables. Okay, as you see, diesel is 7.9, and the age become larger too, because age might have more correlation with the rest of the x variable as well. I just add in. Okay, so this is the variation. I'm going to show you how to leveraging this notebook to calculate your own model, your data sets VIF, right? The only thing, make sure you change in this data set will be importing the right Excel spreadsheet. That second place you need to change is here. Call out the variables in your data set that you plan to use as your x variables, and then you can reuse this part of the code. Okay, in my next video, I will go through the running regression.